at what makes up the mission from the launch until we get to the space station. Here we have the Ariane launch coming out of the jungle in South America. As I said, this has been especially strengthened up to take the very heavy ATV payload. We obviously lose the 2 solid boosters, and going on the main cryogenic stage before we release the fairing. Once we then get off the main stage, we do this first firing of the upper stage, and as I said, then here's the upper stage, and eventually after we'll circle once around the Earth and do the second reboost to get us into this circular orbit. Once we've separated from the upper stage, obviously the first thing that has to happen is we have to get power and communications, so the solar arrays deploy, and also we deploy the antennas so that we can talk to the satellites and to the Earth. So here is the characteristic 4 solar panels, each with 4 wings, with each with 4 panels. And now once we get to about 300 meters from the space station, we start to use this optical guidance of these lasers, which are reflected off the targets which we put on the back of the space station. We have these, this is the primary means, which are called the videometers. But as I said, we have this completely independent teleganometers, which if they see us going off track, they can send us away from the space station. So we come in from this 300 meters, we do a sort of dance with the space station. They're under their own control system, we're under our control system. We're like a pair dancing on the floor. And so we come in very, very slowly, so that we do not collide at under 10 centimeters per second. You can see here the Russian probe extended, which will be caught by the service module, and then we'll be pulled in to make the joint rigid, like any other docking vehicle. This same docking mechanism as both the Progress and the Soyuz have. So that's the mission from the beginning to the end. I think I try to give you some idea of the complexity of this spacecraft. Not only are we the largest cargo carrier to the space station, but we're also the first vehicle which will completely automatically, using optical sensors, dock with the space station. The only action that the astronauts can do, in fact, is they cannot drive us in like they can Soyuz or Progress. All they can do is actually press a red button and send us away if they feel that we're being unsafe. So this is a unique technology that we've developed in Europe, and we're really looking forward to seeing how it works. And of course, any of this automatic rendezvous and docking will be very useful for all the sorts of exploration we'll be doing, going to the other planets with other missions in the future. So not only are we got an exciting vehicle here going towards the space station, but it's also going to be used for future missions. So I think I'd just like to conclude by saying how excited I think we all are now that we can actually see, after a long development time, many small problems, nothing too big, but it takes time to put such a big and complicated vehicle together. And we're very proud that this is Europe's biggest spacecraft, and we're launching it on Europe's launch vehicle. And with the nodes that are already on the space station, and with Columbus, we're now really feeling that Europe is becoming part of the ISS. Europe is going to the space station. Thank you. So I'll hand over to Bob, who will tell you a bit about the operations and how that works.
Good afternoon, everyone. I'd like to, as John says, I'd like to tell you a little bit about how we operate ATV. First, let me say that ESA has quite a history of operating spacecraft, and quite complex spacecraft. In fact, we've had a number of rather spectacular missions over the years. One thinks back to the encounter with Halley's Comet, which we made with the Giotto spacecraft, and also landing the Huygens probe on Titan, were two, I think, defining moments in the operations history of ESA. I would say, though, although these missions were quite spectacular, what we are actually trying to do, or will do, with ATV will be one of the most spectacular things we've ever done. As Alan Thurkettle said, there is a big jump between operating unmanned spacecraft in deep space and actually operating a spacecraft in a manned environment. And it's a big challenge for us, and I think we're up to it. So we're extremely confident. We've done a lot of preparation, and we're ready to go. So let me tell you a little bit about the key players in this mission operation for Jules Verne, and a bit about how we plan to conduct the mission operations. First, let me talk about the ATV Control Center. Maybe I could have the first chart, which is a bit more geography lessons. This is a picture of southern Europe. The ATV will be actually controlled from a control center in Toulouse, which is in southwest France, and it's indeed famous for its good food and its fierce rugby players. However, the city has a tremendous aerospace tradition. In fact, it's synonymous with the Concorde and also the Airbus, which has been developed and produced in, well, a large part of it in Toulouse. But it also is the home of the major technical center of the French space agency CNES, and it's that center from which we operate ATV. Now, a little bit about the history. Why is that? Well, in 1998, ESA's member states took the decision that the Toulouse CNES Center would host the operations of ATV, and therefore we decided to place some contracts with CNES for the development of the site itself, for the equipment that makes up the control center, and also for the preparation of the mission operations. So in 2002, and perhaps I could have the next chart now. In 2002, we started to build what is, and you can see it there from the car park side, a 700 square meter control center, which accommodates something like, I think, somewhere between 70 and 100 consoles for the operators, and houses about 130 staff, which